Hello, and welcome to this ISA Global Cybersecurity Alliance webinar. My name is Matthew, and I will be your IEEE Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading presentation in the upper left is the primary window for today's session. Just to the right of the main presentation window is the speaker bio window with background information on today's presenters. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now I would like to introduce today's presenters, Dale Peterson, Sarah Flukes, and Jacob Brodsky. Dale Peterson has been securing ICS for over 20 years. He is a consultant at Digital Bond and the founder and program chair of S4 Events. You can learn more about Dale at dale-peterson.com and s4xevents.com. Sarah Flukes is an OT security consultant at Admeritia GmbH. As head of security engineering, she is driven by making OT security doable. An automation engineer herself, Sarah is convinced that creating systematic engineering methods, speaking the language of automation engineers, is key for OT security. Besides consulting, she contributes to security and security for safety standards at ISA and IEC, and she has a blog at medium.com/@FlukesFriction. Jacob Brodsky built his career around control systems. He worked on many aspects of SCADA and industrial control systems, ICS, from the earliest stages of design through decommissioning. His interest in cybersecurity started while designing a new SCADA control center in 1999. At that time, there weren't many security guidelines, even in the IT world. So with a bit of trial and lots of error, Jake learned about security the hard way. He has contributed to various standards committees, in particular the DNP3 Protocol Technical Committee. A registered professional engineer of control systems in the state of Maryland, Jake is presently a senior engineer at Applied High Voltage LLC. In addition to his committee work, he co-authored and co-edited the Handbook of SCADA/Control Systems Security, published by PLC Press, and is a contributor to Project Shine. Welcome everyone to today's event. And with that, I'll pass things along to you to get started. Dale, please go ahead.
Thanks, Matt. Well, it's really a pleasure to be here with Jake and Sarah to talk about this initiative, and I'm glad we have such a large crowd today. I want to let you know at the start that we've scheduled about 30 minutes of content, and then the last 30 minutes are going to be discussion and Q&A. So feel free at any time to enter in a question. We'd like to hear your questions, and we'll respond to as many as we can. Let me kick this off with how it first came to my attention. So I got an email from Jake Brodsky. We have a conference called S4 in January, and we had a call for presentations out. And Jake sent me this message. I have a proposal for a presentation on PLC programming tips and tricks for security. Everyone assumes that engineers know how to code, but most do not. And I'm working on a presentation of roughly 10 tips and tricks. Now this email got my attention right away. A lot of times when these things come in, you say, maybe, maybe not. But this was a definite yes. It was something we wanted to see because it was a very new idea. New idea in the sense of the PLC world. If we think about computers, you probably remember back in the early 2000s, Microsoft was having all these problems with worms, really serious bugs taking out a lot of their enterprise customers. So they created something called the Security Development Lifecycle, the SDL. And a key element of the SDL was the secure coding practices. Because what they found was the same types of bugs were being introduced over and over into the products because people were making common errors in secure coding that led to those bugs. So they said, hey, one of the things we need to do to make our products more robust, more resilient, more secure is to actually have a secure coding practice and then teach it to all our software engineers, our software coders, and then include it in the QA process to make sure it actually happened. And we had Steve Lipner at the, I believe it was the '09 event, and he went over this, and some of the people in the ICS world, some of the vendors have actually had an SDL for the development of their code for their HMIs, servers, historians, and such for almost a decade now, and it's really improved code quality. Now, the industry picked up on this idea, and you've seen a lot of these top 10 secure coding practices. You see some of them on your screen here. But it's a real great guide to say, here's some things that we know if you make these mistakes, it's going to lead to security issues. So that made me say, well, if this doesn't exist in PLCs, if engineers are not following these good coding practices for their logic and their programs, then we have something that we can maybe have a big impact on the industry if we talk about it. So we had Jake Brodsky at the event. This is just a screenshot of his video. We're not going to show his video today. You can see the link there to his video. You can also, if you just search on Jake Brodsky S4 PLC, it'll come right up. But it was an excellent video. He was up on stage. A lot of people were talking about it afterwards. A lot of comments like, you mean people don't know this stuff, or people aren't trained on this, or this happens more often than not? And so it got a lot of buzz, it got a lot of attention, and it seemed to be a very good idea. But one of the things we found with doing S4, we started it back in '07, was we had a lot of these good ideas come on stage. And people would come on stage, they presented, the audience would get excited about it, there'd be a talk about it, and then that idea would lay fallow for the next year. Nothing would happen. And it wasn't because people didn't think it was a good idea anymore. It was, we all have jobs, right? We have things that we have to do. We're not really in a position to say, this is going to be my new job to create, for example, a PLC secure coding practice. So one of the things we did with S4 and the S4 tribe, the 700 some people that attend, is we said, why don't we take some of these good ideas, pick 1, 2, 3 from the recent years, and actually turn them into what we call an S4 project. And by that means we find a way to help make this happen. And as you see on the list, I don't have all of them on there, but the PLC secure coding practices was an obvious choice of something we wanted to make happen, or wanted to help make happen after the event the past January. So that brings us to where we are now. Jake had the original idea. Sarah, who's also on this webinar, thought it was a great idea, has jumped right in and actually done a lot of the initial writing and creating. But we said, well, what does a secure coding practice look like? And the answer to that was really easy. We didn't want to create some long 200-page document for people to read. We found these top 20 lists to be terribly effective in other industries. So we said, well, let's do a top 20 list. Let's include documentation examples, and we'll build it out as it goes. We also decided early on that we did not want it to be a standards effort. Nothing against standards efforts. This is sponsored. ISA is involved, and they do a lot of great work in standards, but we wanted something that came out quickly, and we wanted something that could be iterated and updated consistently. So we decided to make it more of a living list and actually put it out there before it's version 1.0. And we've put up a development site. You can see it there, top20.isa.org. That's where a small number of people, mainly Sarah and Jake to start out with, and then we brought a few more people in. But they've developed the initial list that you're going to hear about. But that's where you can get the list, you can contribute to the list, that's where the development of it's going on. And that's open now to anyone. All you have to do is just put your name and email in there. And we don't even check if your name is real. So we want you to contribute. It can be anonymous if you want, you just need a login. Another criteria is we wanted it to be freely available. So this shouldn't be something that someone has to pay $10 even to see. No paywall. And with all those criteria, Jake, Sarah, and I were sitting down and saying, well, where's the right place to host this? I mean, we certainly could put it on the S4 event site, but quite frankly, not a lot of engineers go to that site. So we said, where do engineers go to get information about programming and safety and security? And ISA was the logical choice. So we reached out to ISA and said, would you be interested in doing this? Would you be interested in participating? And fortunately, the ISA Global Cybersecurity Alliance was very interested. They said this fit right in with their mission, and they've been very helpful in setting up this webinar and getting us involved in how we can move this to their site. So the development site will remain at that link, but eventually the list will move over to the main ISA GCA site, and we're really glad that they're involved. So with that as a background as to what the project is and the why, I want to maybe go back to the beginning and hand it over to Jake, where he can talk a little bit about his experiences, about why this is needed, and some of the things he's seen that's been missing in programming PLCs. So Jake, you're up.
Thanks, Dale. Okay. Let me start with how the PLCs get their program in the first place. First of all, it's primarily engineers. They're the people that know the process the best. Typically, it's the same person that looks at the same process and they say, okay, well, it's time to put this to practice, and they cobble something together in a PLC. Let's see, what kind of education did I get? Well, I had a class in Boolean algebra, and I did have a class in a programming language. It turned out to be, I think, Fortran 77. Okay, I'm dating myself a little bit, but you kind of get the drift of what I'm talking about. There's very little background on how to do a good program because we're engineers. We're supposed to know how to program, right? Let's see. And here's the other problem. The PLC programs tend to be very thin and minimalist, and this is where we get into trouble. This list of tips and tricks, this is stuff I have stubbed my toes and burned my fingers on, and not just me, but friends and colleagues and other people that I've talked to over a beer or two. And let's just say that right now there's an awful lot of features within a PLC that remain unused by most people. The primary thrust of this discussion is the focus on self-integrity of the PLC and process integrity. And there are features that we could look for, but we don't. There are anomalies that we could record, but we don't. We're trying to develop this list around the features and things that may already exist or that would be trivial to gather. Let me talk a little bit also about how this happens and why this happens. If you've ever been on a project of any significant size, you know that the control system is usually the very last thing that gets perpetrated before it's turned over to the customer. There's almost always something over budget. There's almost something that's late. It's very rare that you get everything that you were promised when you had time to do this. And people have no patience for saying, well, let's put a little extra something in there to help us diagnose this, because they don't want to hear it. They just want to get out of the project and get paid at that point because, you know, the money's ticking. And then there's a lot of last-minute changes that occurred during the project and the change orders that flew around and the stuff that isn't on the blueprints. So you can't just make these programs ahead of time and then just drop it in the controller and make it go. No, you have to sit down and look at what got done in the field, and then you have to decide whether the program that you may have thought you were going to write is still valid. So this leads to what a colleague of mine used to call a drive-by integration. And that just means that somebody ran past the PLC, sprayed a program in there, and ran away screaming. And that's not a good way to write code, and it doesn't help us. So we need to have a conversation, if nothing else, about how we do this piece of the business, because it's not serving anybody well. And I think with that, we head to you, Sarah.
I think I'll end up with a presentation of how we organize the project, how it's set up, how you find your way through the platform, and also my thoughts on why it's important and why I jumped right in. If you look at the discourse site where it's hosted right now, you see pretty much what you're seeing here on that screenshot right now. So the important part is really the current top 20 list, where you see exactly the content you're seeing right now. And it's really just a headline and a short description for every practice. That's the content that Dave was talking about, that we really wanted to be short and precise and above all usable. So it's designed to be a list. It may not be there yet, but it's designed to be a list eventually that people can use as reminders when they do their programming and their architecture. Speaking of architecture, what we have here is mostly really programming practices, but we have in the discourse platform a lot of practices that may not strictly fall under programming. And we try to group them somehow. The grouping is still preliminary, so it will probably change, but that was the basic idea of how do engineers that really program PLCs, how do they look at their systems, and how do they think, how should we organize the list in order to make it easy for them. So we came up with just grouping them more or less according to Purdue levels. That was the obvious choice. Didn't want to make something complicated. So you see every item on the list has an ID attached to it. That's the blue thing you see here. It's blue because it's a link. If you click on it, you can see more details. And the ID has a first digit, which is really the grouping. So 0 is for process, 1 is for I/O, 2 is for PLC programming, and that is the reason why most of the practices you're seeing here right now has a 2 up front. It's not because we have 200 in the back, but it's because it's a grouping of 2. Then we've got 3 for HMI and 9 for general, which is really the melting pot for everything that doesn't fit in anywhere else. And this is something that will truly get extended, and that is one point for discussion, but we come to that later on. So if you see these examples for the list and you click on one of these details, you get to the details for the practice, and we see an example of that here, or better, we see a template here. How these practices, the detailed practices, the detailed content is structured. So the idea really is how to have the practice title and a short summary, and the title and the summary are what goes to the list, to the top 20 list. And then we wanted to have a page that provides further resources that help with implementing the practice. So that would be guidance, everything that helps for implementation, or any background information that helps understanding the practices could go into guidance. We've got a section for examples, which would be anything that helps either understanding how it's implemented, so really give examples how it's implemented, give examples for what happens if it's not implemented. That's also a good choice. They don't have to go in there. All this content is optional, but we wanted to provide the opportunity to fill that in and give it some structure. And then we've got the section Y that really is closest to my heart, because I think that's the, on the one hand, the motivation for engineers, which may not always have security as their major goal when programming PLCs, but still it's the motivation to explain to them and explain to the community, explain to each other why a certain practice is a good idea anyway. And the key point is, it's really not only about security, and that's what we're making very explicit here. What benefits security can also benefit a lot of other things that are really do earn money. People always say security doesn't create any revenue. That's right, but reliability and maintainability does, and that's a big chance to outline that. And was also a point really important to Jake, who said it's not at all about security, it's mostly about integrity and just doing your stuff in a way you can maintain it. So that's what you can really see here. I promised an example you're getting here. That is the example. We chose an easy one to make it fit on the slide. It's ID 216, and it's also on the list of the top 20 so far. You see the first number indicates the grouping, so it's the practice for programming, and it's about validating inputs based on physical plausibility. And that really is an example that shows how much you can use what's already there, what's particular for PLCs, in order to achieve things that you would achieve totally differently if you had secure coding practices for IT. So that's why it's important and why it's interesting. So we just quickly go through the example in order to make you understand how it works. So you have the headline, you have a short description, set a timer for an operation, the duration it should physically take. So this is really the idea, to use the knowledge of the physical process in order to validate what's going on, and in order to have an alert if something's the integrity is violated in any way. You see the guidance part is used here in a way to say, okay, what are examples, or what's the reason why you should do that? If it's going too quickly and it's going too fast, there's both good reasons to raise alarms. You see in examples, most examples come from Jake's experience, so you see a lot of water and wastewater examples here. We're always happy if we get others, but I think they do the job here quite well. So an example is if you have a gate on a dam, and it usually takes a certain time to go from fully closed to fully open. So if it usually takes a minute, and then you have a situation where it goes from fully closed to fully open in 5 seconds, that's probably a good reason to investigate, unless you purchase the lightning speed gate. And the second example is a wet well that takes a certain time to fill. So these are examples where physical processes really do take time, and it makes sense to alert integrities or set timers on in order to get an idea if integrity is violated. So that's a trivial thing if you put it down right here, but that's the power that Dale was talking about, because if you have a list of a lot of trivial things that just call for a little thinking before your program, and a little list of easy tricks to apply, that may go a long way in combination. And also here you can see why why a practice like this is not only beneficial for security, because of course deviations from a normal state can have different reasons. If you're thinking about why a gate, for example, takes a longer time or a shorter time for an operation that physically should take longer or shorter than actually does, then you could see, okay, maybe the actuator is just in the middle of a travel state. That can be any reason, but it also can be a reason for someone trying to fake out I/O. So it really doesn't indicate something that's really physically happening. So that could be used that way, but obviously there could also be reasons that are just due to broken equipment or anything. So that's also something that helps you with just reliability or maintaining processes. So much for the example. I'll end that session before we come to the next steps and then to the Q&A to point out that, in my opinion, this project is not only interesting because it's obviously needed and it could really be helpful for people in their daily business, but also because it could serve a couple of purposes for security engineering in general. Because I don't know about you, but I've had many situations where we started a project. As said in the introduction, I'm a security consultant, so we're starting out a project in an OT environment, and for example, are going through ISO ISC 27K controls, security controls, and inevitably, at some time, we end up at a control about secure development. So you're starting to ask people, okay, do you develop anything? And they're all like, no, of course you don't. We're like, okay, are you sure you're not programming anything? No, don't have any software development going on? And they're like, well, actually, no, not really. I mean, we do program PLCs, but that doesn't really count, right? And at that point, you're starting discussion. At that point, you're starting discussion about, does PLC programming count as programming? And then and exactly that point that they pointed out earlier, saying, okay, I mean, if you really do want to make PLC coding secure, what would we do? Because for IT, there are secure coding practices. But if you look at the secure coding practices for IT and try to just apply them to PLCs, you run into a lot of problems. And a lot of those problems make it really easy for people to back off and say, well, okay, if that's the secure coding practices, they're just not applicable to PLCs. So what we're doing here is really a big chance in order to show two things. One is blue on the right, one green on the left. I start on the right. I said that before, and that's why the why is so important. We have the chance to make really explicit that for security, for PLC security in that case, for OT security in general, I think that's also oftentimes that's also true. There's that myth that security never earns money and you can only have security or usability. There's always a trade-off. But if you closely look at the PLC secure coding practices we already have, that's mostly not true. So we may want to challenge that myth, and we may want to challenge that for PLCs, but maybe also for OT security engineering in general. So oftentimes what helps security also helps on the side things like maintainability, like clean engineering, like reliability, maybe even sustainability. And then we have the point on the left. With that, it's often difficult to, and that's also something that's true for security engineering in general, OT security engineering in general. If you just take the IT security practices and try to transfer them to OT, that doesn't really work, and it's often an easy excuse not to do anything at all. But if you look at the PLC secure coding practices that are already there, you will notice that the special thing is that they take the same goals like IT security. For example, they want to do integrity checks, but they just look at PLC particularities and see how they can use these particularities and use them for security purposes. So don't try and create anything, transfer anything from IT to PLCs and try to avoid the problems that PLC particularities make, but regard all these particularities as features and try to make them usable for security. Use what was already there and do the PLC secure coding practices from then on. And a lot of the practices we already suggested follow exactly that path. So there's two main features. I'm sure you could extend on that, but I'm not doing that today. So PLCs always control physical processes, and you can't really fake laws of nature. So that's one thing we've seen in the last example we've been talking about. Physical processes take a certain time. So we can use that knowledge and that feature in order to, for integrity checks, for example. And that's a second thing. So PLCs are always deterministic. That's one of the main features why they're there in the first place. They have to ensure real time. So in a system that's deterministic, obviously it's way easier to trace anomalies because it's so well defined what's normal. And we do have two PLC practices that make use of exactly that. You will find them in the list. One is about the scan cycle time, which usually doesn't change, and if it does, you should keep an eye on that. And the other one is I/O power consumption. That's usually not something in a normal computer that would be of any use, but for PLCs, that's really of a lot of use because it's usually so predictable. So to round things up, I'll give an outlook on the next steps and on open issues that we still have for the project. So the obvious next step is that we review practices and that we add practices. So we want you all to see what's there, and you want to debate about what's missing, what's there but debatable, what's there but maybe doesn't fit for all vendors, might be needed to be redesigned. What's there but not understandable and needs better explanations. That's all comments that we're really looking forward to, and please don't be shy and keep the critical comments coming because that's really important that we do that. We have, the second thing is structure and usability. So we're still looking for improvement for a structure that helps, I mean, 3 target groups that we identified already: engineers, security professionals, and maybe even management, to work with the practices, or to at least understand them, communicate them. We've got a third task that is adding background knowledge. So while we were talking about the practices, mostly Jake and me over the phone, we had a lot of issues where we said, okay, actually, even the guidance chapter is not enough, because we would have to explain a lot more general things that are actually important to understand a lot of these practices. And maybe that's not important for engineers, but it may be important for a target group of security professionals to understand what's the basic, how a PLC basically works, in order to understand why a certain practice is important. This could be a collection of links, this could be good literature, but this could also be content that we're creating and putting on there. For example, models that explain typical hardware, software, or the scan cycle better, to see a small picture on the right, how this could look like. And then the last point, which a lot of you already mentioned to us before this webinar, which we're really thankful for, is that we could also, and we're planning to, of course, reference and build upon existing work. I'm seeing mainly 3 categories in there. So first, obviously, we should pay attention to what's already there in PLC coding guidelines. Maybe we could build upon that, maybe we could enhance that, maybe we could at least reference it. Same for secure coding for IT. It's not directly applicable, but maybe some things are comparable, and maybe it makes sense to reference things and say, okay, see, we are achieving exactly the same thing like Microsoft in its security development lifecycle, but in a different way, which would be really important for IT people to understand OT better. And then we have the last thing, which is security standards or frameworks. The obvious thing everyone talks about right now is ISAGCA and ISAGCA 62443, but there could be a lot more. And that really is also input that we are always happy to receive and that we're going to discuss on the discourse platform. And with these open questions, I'd like to open the Q&A and hand over to Dale, who's going to organize and read the questions.
Great. Thanks, Sarah, and thank you, Jake. I want to just, well, first of all, let you know you should send in your questions right now. We've got a lot of great ones. We're going to try to get through as many as possible, as quickly as possible, so send them in. You should be able to see a Q&A button on your site. Just send them in and we'll knock them out. But I want to acknowledge that Jake and Sarah put a lot of work into this. Jake with the original idea and contributing a lot of content, and Sarah just did a huge amount of work in actually creating the content that you see right now that's up at top20.isa.org. All that said, as I think Sarah alluded to this and even mentioned it, we view this as a work in progress. So the structure could change, the 17 practices that are in there could change. We're really looking for feedback, but it's very difficult to start something like this without a straw man to start, or I don't know if it's straw man's the right term, but something to actually comment on and work on. So don't view this as even close to finished product. Any one of the practices could be pulled, any one of the practices could be altered, we could change the way the documentation is done. This is just a starting point for the community to engage in. So that's a big part of it, and I want you really to contribute as much as you think you can help. We've got, rather than seeing our smiling faces as we talk, we thought we'd loop through the practices so you can see some of them on the screen while we answer the Q&A. But as they were coming in, Sarah and Jake, I noticed a lot of the questions were scope-based related. For example, Prashant asked, do we have a standard guideline for PLC with secure boot and prevent from access denied attacks? And I think one thing we need to clarify, and you can check me on this, but this is really geared at the engineer programming the PLC, not features that vendors should include in a PLC. Is that correct? Would you see secure boot being something that would be on a list like this? Maybe I'll throw that to Jake.
Yeah, I mean, a secure boot PLC is a good idea, and I'm hoping that as time goes on, more and more vendors head that way. But it's kind of out of scope here. We're talking about what the engineer puts in the PLC about the process, and that piece needs to be fleshed out a lot more than it currently is. The secure boot, of course, is a very nice piece of that, but it's only on the periphery. On a larger note, I want to point out that not all of these things are applicable all at once. There are features in here that we would think that you might want to use in some situations, and there are features that probably should be left behind. And maybe that should also be part of the discussion. So we've got time. I also noticed some other questions in here. Let's see. There were some really good ones about.
Jake, there's one that's related. There's one that's related to that a little bit. So we don't want this to be something that we want this to be things engineers could do. But I thought there was an excellent question from Mandar. He said ID 205 and 218 can be part of a PLC programming software tool itself that is default. Have you talked to any vendors regarding these possible features in their next version? We haven't talked to vendors about this yet. It's way too early. But while we said this is something, it should be something that engineers can do, much like the Microsoft, much like in Microsoft developed tools that made it so that secure coding practices were something that were just done. It was difficult to not follow them because certain functions couldn't be called and such. In theory, a vendor could look at some of these and integrate them into development packages. Sarah, maybe you and I have had this discussion. Maybe we can talk a little bit about it here. You talked about the structure with the 0 for the process, 1 for I/O, 2 for PLC, 3 for HMI, and 9 for general. I guess, why don't you talk a little bit more about, for example, why in a PLC programming, PLC secure coding practice, why am I having a practice for an HMI? That's not really a PLC. What was the decision to include that?
Well, I guess we actually looked at what's important to a PLC, and then came across a lot of things that are not, especially not just for programming in the PLC, but also for surrounding equipment. And there are things that are connected. So, for example, if you allocate certain register blocks for the HMI, you're obviously talking about what the HMI does, and there are things that you might want to do in the PLC, but it's a better way to do in the HMI, and we didn't want to leave them out.
And what did you have in mind for the general category?
First, that was an amazing thought for the rest. But secondly, it was things like architecture, so things that you couldn't really put to any level of the Purdue layer or any system in general, but which was just about architecture and how to connect systems, and also about things that are about communication and organization issues. So we've got one practice that's only number 9 on the list already, that is about putting PLCs in your control system narrative document. And that doesn't really fit into any programming or any HMI or process layers, but it's important nevertheless, so we wanted an option to include things like that as well. Also because these number 9 practices, and we might add a simple category just for communication, will be important in order to communicate the aspects that are important for management. That was also one of the 3 target groups that we identified that are important to have in mind when writing about the practices. And obviously, management probably won't be the one who care about dedicated register blocks, but they will be caring about things like where do we put the practices in order to have people really adhere to them. And that's something you could put into 9 or anything that's still coming up.
Okay, a couple more scope questions there. Let's see, this was from Keys. He says, it looks like PLC Secure Coding Practice will try to build a PCS DCS system from a PLC. And we had another question that said, do these practices apply to DCS controllers? Do either of you have a thought on that?
Yeah, PLCs and DCSs have been kind of growing towards the same thing for quite some time now. And in fact, some vendors such as Rockwell have started calling their products programmable automation controllers to distinguish themselves from, say, the earlier versions of the PLCs that were strictly logic. And I think at this point, the big difference between a DCS is that the DCS basically comes with all the features available to you right in front of you. What we're talking about are enabling a few small features, keeping things simpler, and just using the extra security features where they're needed. So that's why we're discussing the security features. It's because most PLCs don't have all the features or don't advertise the same features that the DCS does. But at the end of the day, this is rapidly becoming a very blurred definition in the first place.
Okay, that's good. We're getting some great feedback. We need to capture a lot of these because this is the kind of feedback we want for the list. For example, Vivek says these new alarms being proposed are really alerts per ISA 18.2 and tagged as security alerts so that they are sent to the maintenance techs, engineers rather than the operators. So that's a good point, and we might even have some of the basic terminology wrong. So we'll definitely take a look at that. There was a question about an item on network communication is probably also required as a separate group. Each protocol used between I/O or between the PLCs or HMI and PLC require also best practices. Sarah, would you see that as something that would be integrated into this list, or is that something else, these ideas of protocol best practices?
I think that's absolutely something that we can integrate. It's really, I don't know if you will end up in the end with one top 20 list, or if you will end up with 3 top 20 lists for different audiences or different perspectives on the list. I think it really depends on what kinds of ideas people bring in, and we really wanted to limit this as little as possible at the beginning. That's why we also didn't really go into details regarding categories, because they shouldn't be considered as fixed already. They can change, and there's a reason why after number 3 comes number 9, because there's at least 5 categories in between already that can be filled.
I think one of the challenges always in these lists, and this is one of the things that the standards efforts always struggle with too, is we want this to have an impact to be useful. So limiting it to 20, and it could have been a top 10 list, but limiting it to 20 has some value because it says it makes the effort try to determine what are the most important 20. Rather than saying you must do this 100 things if you can only, and I'd actually like to see them in priority order, but I'm just one voice in this. But we've got 17 in there now, and my expectation is, just based on the number of people that have looked at it, that some of those 17 will drop off, not because they're not good practices, but because there are other practices that the tribe that's putting this together will view as more important. And we'll see how that goes.
I think you could really look at it as something like a soccer league, or football league in America. That's just a competition for the best practices. And we do have a list of about 30 more candidates, and there's still more to be added, and I think there will be more added within the next days, and we already have some comments, some people adding practices, and that is great, because if you add candidates and we have a discussion on which should go up, in our soccer league of top 20 coding practices, then we can do, and you can also drop out if you don't perform. So that's okay.
Yeah, maybe we'll have relegation every year. The bottom 3 drop off, and we had to find 3 more important ones or something. Jake, you wanted to say something?
I mean, yeah, I was going to mention another example. One of the items on the list was doing boundary checking for arrays. And, you know, if vendors would include a module to do that within their own products, that would then remove it from the list, because right now, many PLCs on the market, and I don't know exactly which ones, and I'm not going to mention names because it doesn't help, but many vendors will not check to make sure that you haven't run off the ends of the array. And if they don't do that, then you can do damage to your own code and your own data structures. And this is something that I hope I talked about how to do defensively, but at the end of the day, we really shouldn't have to be doing this. We should be creating a fault or an exception, and then people should be reacting to it that way.
You mentioned different vendors doing different things. There was
of making this a to-do list for vendors and dropping things out of vendors have achieved them just by default. I mean, we as a security community always strive to make ourselves superfluous, right? So that's a good idea to give to hand over to vendors and say, hey, can you achieve that people don't have to think about that as much anymore, and do some things, check for some things by default, and then you can drop out of the list.
Right, and I think that's why we see some of the errors or some of the issues on your list. Excuse me. You don't see those in application software as much running on computers because the compilers automatically deal with that. The tools don't let you do these bad things. Jake, though, I wanted to hit this. I think this is an important one. How universally applicable will the top 20 list be for different vendors and different systems?
Well, there are some that are definitely ahead of the curve, and there are some that are just interested in producing an inexpensive product. And neither one of these approaches is wrong. So let me just staunch any further discussion about, which is right and which is wrong right there. If you're buying an inexpensive PLC because you're working on something that's cheap that doesn't have any real social impact, if it fails, then fine, get yourself a cheap controller. And if you're trying to do, let's say, critical infrastructure, you're working on a nuclear power plant, and you want that PLC to handle the, something to do with the reactor, well, maybe you should get a good quality PLC, maybe even a safety-rated PLC. And then what are your tactics going to be when you actually start writing the program? So there's a spectrum of opportunity and market in there, and I'm not going to besmirch a vendor simply because they're producing an inexpensive product.
I think that's one of the main points.
I'll throw it to Sarah.
I think it's one of the main challenges we're having. Make this list as vendor independent as possible. And it's also some of the first comments I actually got from the German community looking at these practices saying, this doesn't really sound like Siemens. And this is probably one of the challenges we have to meet, that it makes sense for people programming PLCs regardless of what vendors they're using.
Yep, I think that's important, and I think that ties to some of the feedback that we'd like. We actually had some internal discussions on this and some disagreements, and that's good but there were only 3 of us, so I didn't push it that far. I'd like to see a lot more feedback on that in terms of the practice itself needs to be short, a couple of lines, but then what is there for documentation and examples, and you'll see the why section in each one of these is really important. Like, we had a discussion, do we need separate documentation for the security professional versus the engineer because they come at this with different perspectives, or should we try to integrate those together? And I think that's where we can really add a lot of value to this is making it understandable, and it could even have some potentially different documentation, whether it's a DCS or a PLC or an expensive one or a cheap one. I guess we're just looking for a lot of feedback on that. I want to ask both of you this question. Are some of these practices based on exploited security issues that you've known of? That's a question from Ralph. Jake, your practical experience drove some of this, so I would imagine the answer for you is yes. Did these come from real life issues you've run into?
Almost all of them have. I'll give you an example, and this occurred in a water treatment plant, but you see these processes in other places as well. It was a filter backwash step system, and there's about 16 or 18 steps to a backwash, and every step that you do has to be timed. We discovered in a rude experience where we accidentally wrote the wrong value to the timer, and why it got written that way? Well, the HMI had the wrong scale factor in it. So we ended up writing a value that should have been 300 seconds. Instead, it was 3 seconds. It was off by a factor of 100. And the step kept timing out, and because of all the other complexities concerning the backwash, we got very confused. And that's when we realized that if we didn't keep our act together, then we had to get everybody together to start talking about how could we make the PLC program more robust so that we don't step on ourselves and make this more difficult than it has to be. There are other things that we've crept into as well, like how to interface with the network people. You've got the people that do the OT networks, and they may have a firewall device that is protocol sensitive, but they don't know what's going on in the PLC. So because there's so many different things that you could be writing to the PLC, it gets really difficult for them to keep track of all those different registers. So we came up with the idea of let's group everything into an array of registers, and only that array gets read or written. And that keeps the firewall simple. It makes it fast to get through, and then you look at what the PLC program is doing. It also gives you a place to validate all of your I/O going in and coming out. So these are sorts of things that we've stepped on and burned our fingers with. And a lot of these ideas that you see here, including the documentation one at the very tail end, these are things that we've learned the hard way. So don't just dismiss this right away and say, well, that's documentation, that's not actual programming. Oh, yes, it is documentation, and it's documentation that'll help you in the middle of the night some night when you're standing out there flummoxed looking at the PLC. So that's just a taste of where this came from and how it got there.
Sarah, you came up with some of the practices as well. What did you use as inspiration? Were there actual things that you saw, or did you just tie it into secure coding practice in general? Did we lose you, Sarah?
Was it me? I didn't get the name. We would directed that again.
Okay, actually, but yes, did you go ahead then.
It's okay. We actually discussed, I mean, you made the comment when we first put that into the list. You made the comment where this is not programming. Does it really fit into that? And Jake and I actually spent like half an hour discussing that question. And then we agreed on that really makes sense for more or less the reasons that Jake pointed out right now. And I think it's important too because from my experience, secure practices and doing things right when you're programming them are important. But in the end, in most cases, when we start a security project, the first thing we have to improve is documentation. So it doesn't really help if you have one person, one engineer who perfectly programmed his PLC with all secure coding practices in mind, but never documented why he did all that. So there might be the next engineer looking at this have no idea why the engineer coded it that strange way, and he might not know about secure PLC coding practices. So he has a hard way to find out why things are there, and this is why this could be a good idea to really have the need for this documentation right in the top 20 practices in order to have people not forget that secure PLC programming doesn't end at programming.
You bring up an important point here when you're actually talking about the programming, and this is why I always defer to you and Jake on this, and I think it points to who we need looking at this. Obviously, we invite everyone to look at this, but if we just had people with a security background like myself looking at this, the list would not be right. We need that's good input to the list, but this is really an engineer's list. These are things engineers need to do, so we need people that are involved with actually programming these systems, these PLCs, and other level 1 devices. We need them actually to comment. I think that one thing related to this, Jake, in your initial proposal and your initial session at S4, you talked about the training issue. So at the end of the day, we create this list. I would hope that at some point, beyond just the list, there might actually be some training involved in this. But talk a little bit, Jake, we're running out of time here, but maybe give a quick comment on engineers training and what we need to do to get them to a point where they could actually follow some of these practices.
Well, one of the things is just to show people that there's some really good ideas, for example, in lots of different places, but nobody has actually collected these things into one place. The training that we would do with an engineer, for example, is I'd like to have them, instead of writing traffic light programs, have them write a program that fills a tank or empties a tank and monitors what's going on, what's the flow rate coming out of the tank, and have them discuss all the different things that could happen. And the reason why we discuss this is because usually PLC programming classes are very, very narrowly focused. They're interested in showing you how the features of the PLC work. They're not really interested in showing you how to make a good process work. And so the training that we have to talk about has to be more focused on the process, which then brings you back to the documentation. You know, you should have a program narrative so that not only does the engineer understand it, but there's a document that the operators can refer to so that when something weird starts happening at 2 a.m., they can open the document and say, oh, that's a mode that the engineer allowed for in case of this, and then they can dismiss it and not have to call anybody. So it's a very handy document to have around. So talking about how to write that documentation, how to talk to a lot of different concerns about how people write these programs. Anyway, we're running short on time. I could babble about this all week. So.
Well, thank you. Yeah, we are running short on time, and I do appreciate all the questions that were sent in. We're going to get those questions, and some of them were on very specific items, on specific practices, and that's the type of feedback we want, and we're going to answer all these questions, and we will send you a link where all the answers are available. They will be on that top20.isa.org site. We'll include the questions and answers there, and we might weave them in to the specific practices where they made sense as well. We'll find the best way to get this initial push of feedback. But that's what we're really looking for. We're looking for, whether it's yourself or someone on your team, to get on that top20.isa.org, improve it, add to it, critique it. We're looking for your feedback. And I just want to thank, one last time, I want to thank Jake for coming up with such a great idea, Sarah, and also the ISA Global Cybersecurity Alliance, because I think at the end of the day, they're going to help get this message out there to the engineers, and so that we don't just want to create a list and have it sit there and say, hey, we all won, we created a list. We actually want the list to be used and have some impact and maybe drive training programs and other things. So with that, I'm going to turn it over to Matt to give you some information on the replay and close this out. Matt?
Great. Thanks, Dale. And thanks, Sarah and Jake, for that great presentation. And of course, thank you to all of our audience members for being part of this webinar event. You will be receiving an email from us with a link to the on-demand version of this presentation, so you will be able to come back and watch this again or share it with colleagues. And lastly, please take a moment to complete a survey which will appear on your screen at the end of this live webinar. For on-demand viewers, you will find the survey located along the bottom of your attendee console in the survey widget. Again, thank you for taking the time to attend this webinar event. Take care, and we will talk with you soon.